AP Calculus, Section 6.1, Antiderivatives, Differential Equations, and Slope Fields, page 4. We are going to be looking at a slope field that is dependent on both x and y. And this is the slope field. dy dx is negative x over y. So we are going to start by looking at what happens if x is equal to 0. If x is equal to 0, then we have 0 over something, which is 0. So dy dx is 0. Those are all horizontal tangents. So anywhere where x is equal to 0, we'll draw in a little baby horizontal segment. And if y is equal to 0, then dy dx is something over 0, which is undefined. That's a vertical tangent. So wherever y is equal to 0, we have some vertical tangent pieces. And the one point that I kind of skipped over and didn't draw tangents in there was right at the point 0, 0. So if we have the point 0, 0, then dy dx is 0 over 0, and that's just ugly. It's not undefined, it's not 0, it's just kind of ugly. So we are not going to worry about that one. And let's go ahead then and just calculate some slopes at other points. And if we look at the point maybe 1, 1, that will be negative 1 over 1, which is negative 1. How about the point 2, 2? That'll be negative 2 over 2, which is also negative 1. So we can see by these 2 points and by thinking about this differential equation that if the x and y values are exactly the same, then the slope is negative 1. To draw a slope of negative 1, we're going to use the dots on the paper as if we were drawing long lines. So right here, lining up the dots to show a slope of negative 1 right there. Keeping my ruler and lining up the dots for a slope of negative 1 here. If we look at some other slopes, and I'm not going to put them in the chart in the table over here, we can just think about them. This point is 2, 1, so the slope will be negative 2 over 1, or negative 2. So from that point down to and over 1, take the ruler then and line up those dots from here's where we started, down 2 over 1, and we put a little baby slope segment there. That one has a slope of negative 2. This point right here at 3, 1, plugging in, that's a negative 3 over 1. So from that point down 3, 1, 2, 3, and over 1, line up those dots with a straight edge, and there's that slope of a negative 3. Negative 4 slope's going to be a little bit steep, so we're just going to stay kind of within this box here of 3 by 3. Looking at this point, that's 1, 2, so slope will be negative 1 over 2, so negative a half, down 1 over 2. And this one, that point is 3, 2, so that slope is going to be negative 3 halves. So down 3 and over 2. We're going to have to estimate there to get that one. This one, the point 1, 3, has a slope of negative 1/3, so down 1 to the right 3. When we line those points up here, and this next one, 2, 3, down 2 to the right 3. And there's that slope. So we have this slope field started here. I've done the first quadrant. you guys pause the video, seriously pause the video, and go draw in the second, third, and fourth quadrants. I mean it. Pause the video and go draw in those slopes. Welcome back. I've put a completed slope field up here, and you should see something like this. When you look at that, do you see a bunch of circles? You should see a bunch of circles in there. And we've actually done this derivative before for a circle. So let's just make up any radius, maybe radius 5. That'll give us x squared plus y squared equals 25. When we do the derivative then, implicitly, we have 2x plus 2y times dy dx equals 0. The derivative of 25, 0. The derivative of that y squared, 2y times dy dx. Solving for dy dx, move the 2x over, divide out that 2y, simplify, and there we go. Dy dx is negative x over y. Negative x over y. All right, now there must be an easier way, we hope, and actually there is. There's a program that you should be getting from your teacher called Slope Field, and I already have it on here, so I'm going to go run it. And there is that slope field program right there. Cool. All right, just a couple of quick comments. See this kind of diamond shaped in here in the middle? We don't see that over here, and it has to do with the way that this program draws things. If you look at this one, we look like we see a slope of -1 right there. There's another one that has a slope of -1, and another one a slope of -1. And if I look back over here on mine, had I made this slope of -1 just a little bit longer than what I did, and this slope of 1 over here, we would have seen that diamond shape that's in the middle. So the tangent segments are just a little bit longer here, hence you see that diamond. Okay, please make sure you get this program from your teacher and that your teacher has showed you how to use this program before you look at page 5. Thank you.